So, as I was telling you, at the market equilibrium, consumers maximize their utility. It is the place at which the greatest amount of consumers you can satisfy is being satisfied because of this equilibrium price, and producers get the maximum profits they can obtain at this particular price. That is the idea of the market equilibrium we were discussing. To calculate the market equilibrium, we essentially need to do a couple of things. The first thing implies equating the demand and supply curves. So for simplicity in this course, we will model demand and supply curves are actually as lines and not as curves. Why? Because if we would not do this, the market equilibrium would be more or less simple to find. But when we wanted to calculate the profits or the consumer surplus, we would need to use integral calculus to basically find the area beneath those curves. And the mathematical operations become much more complex to represent the same economic concept. So we're going to simplify the math and just focus on basic high school algebra. So if we have a demand curve and a supply curve, as you see there in the slide, and obviously they depend on P. P is the price of the good. You have other letters there, A, B, C, and D, which represent parameters that we will discuss next class when we do a typical example or a normal example. But the point is that you want to find the place at which they both intersect. So to do that, you need to equate both lines, the C plus DP of the supply curve and the A minus BP of the demand curve. And you can do that because both of them, whether they are the demand or the supply, represent a quantity. In the case of the demand, it is the quantity demanded can be obtained from this particular function that depends on the price, A minus BP. The quantity supplied to the market, the units those producers place on stores to be sold, can be obtained from this particular supply function that depends on the price, C plus DP. So because both of them can be related on the idea of the quantity, and you want to equate the quantity demanded by consumers with the quantity supplied by producers, you can equate these two lines as I'm showing in this particular slide. And if you do the algebra and solve for the price, you find the market price or the equilibrium price, P star. At that price, you can exactly find the equilibrium quantity that satisfies this condition. And that's the next step. Once you've resolved the algebra for the price and solved for the equilibrium price, you substitute and plug back in that price into whichever one of the demand or supply functions you want. Both of them work, and you can find the particular quantity using that price. So as you plug in and you simplify the algebra, you will find the equilibrium quantity that obviously depends on the same parameters that you were using, and you have the equilibrium price. And with that, you basically have the equilibrium point, which is a combination of price and quantity, or quantity and price. As you can see right now in the slide, you basically find that particular intersection where the demand and the supply curves meet, and that it is defined by a price at which the quantity demanded by consumers is equal to the quantity supplied by consumers. So in this particular case, as you see in the slide, you have been given a demand and a supply function that take that particular forms, or those particular forms. The demand function reads that Q, the quantity demanded, equals 66 minus 3 times the price. And the supply curve indicates that the quantity supplied equals minus 4 plus 2 times the price. So how do we find the equilibrium price and quantity? Yes, you need to equate them, exactly. And once you equate them, what happens? You have two equations with two unknowns, but you equate them, what can you do? So let's just copy both of these from this slide. And let's start solving it here in the slide. Obviously, this is much harder to do on the computer than on the board, as you would imagine. I would normally do this on the board really quickly, but it is what it is. So if that is equal to Q, then you also have this thing equal to Q. Right? So now that we have we can actually solve for P, which was Pamela's suggestion, and we will just do that. So I'm going very slowly and doing every single step such that you do not get lost on the process, which is actually really simple. It's like high school algebra, but maybe it's your first time seeing these type of things applied for an economic problem. So let's do it this way. So to solve for P, what we need to do is pass P to one side of the equation and the other numbers to the other side. So I'm basically just gonna pass P to the right side of the equation. So in this case, if I pass a 3p to the right side, what I am left with is 5p. And if I add the 4 to the other side, what I'm left on the left-hand side is 70 equals 5p. And with this in mind, it's actually really simple. What we have is that 70 divided by 5 equals 14 equals the equilibrium price P star. And just like that, in a simple algebraic calculation, we have found the equilibrium price of this particular problem. That is the price at which the quantity demanded and the quantity supplied are the same. Therefore, we can find what is the quantity that satisfies both consumers and producers. So if we have a 14 price, let's just, this seems easy enough. So by substituting back into any of the original supply or demand functions, we can find the equilibrium quantity. And by plugging in the 14, we can find the actual quantity. So in this case, the supply of 14 equals 2 times 14. 2 times 14 is 28. Minus 4, this implies that the actual supply curve grants us a new equilibrium quantity. Where are we? There we go. And just like that, we have found both the equilibrium price and the equilibrium quantity. Pretty self-explanatory, pretty simple, and I think that's what I actually place here. And with this in mind, I can return to project in the full version of things. Basically, at this particular point, at the price of 14, consumers buy 24 units of this imaginary product. Any questions regarding how we got here to the equilibrium point?